Hi there. Yeah, so I thought I should make a quick video explaining linear regression and how you can implement it in Python from scratch. So, this is the video that is going to be about. Okay, so this video will be roughly divided into three sections: dataset exploration, data pre-processing, and then the linear model, which will include cost function, gradient, and then gradient descent. So, I hope you enjoy. And if you do like this video, don't forget to like and subscribe to my channel. Anyways, so what is linear regression? Well, if you have a data set like this, it's just fitting a straight line through it. We also call it a best fit line. How do we do it? Well, we use cost function and gradient descent. Now, coming to the fact, what is a cost function and what does it do? Well, a cost function minimizes the error and it is represented as a function of W and B, where W is the weight and B is the bias. It is written as following, where M is the row or the data values, fx is the function wx plus b, and yi are the labeled values corresponding to the values of x. What is a gradient descent? Well, it is whatever this thing is. And we repeat this thing until it converges. And why do we repeat this? Well, because of errors. Now, if you visualize it this way and plot the function jw versus w on an x and y plane, you get a curve something like this. And we want this point right over here because this is where the value of w is the minimum and the function of w, which is the jw, works the best. And if you include b as well and it becomes a function of w and b, which is represented as jwb, well, we get 3D. Now, coming to the fact, what is the dj, dw, and dj, dp? Well, they are the derivatives of the function jwb with respect to the parameters. Now, this looks something like this. So now we have these three functions and we are pretty much ready to build our first linear regression model. Okay, so let's get this thing done. So the first thing is importing packages, and these are the few packages that we'll be using. It will be NumPy, Matplotlib, Pandas, Cball, sklearn, and from sklearn we will be using train test split and standard scalar. Now that we have imported our packages, what we'll do is we'll import our CSV file, and that we can do by using the functions in read.csv in pandas, and we do it something like this. Well, while going through the visualization of the database, what you will notice is that there is a column called ocean proximity and it doesn't have any numerical value. So what we can do is we can one hot encode these all these values and join it into a one major data set, and then we can use that for our linear regression model. One more thing to notice is that when we will use the info function and we get these values, what we'll notice is that in total bedrooms there are 20,433 values, and out of that there are null values in there. So around 200 something values are null values, and we can remove them because it is very fairly a very small number. So we go on and drop those values, and we also do the hot encoding thing. And we can do this by using the functions in pandas, that is get dummies. In get dummies, we have to first given the data set that we want to use and the columns on which we want to apply the one hot encoding. Then we use a function drop first equals to true because we don't want the original one ocean proximity column to be there, or we only want the one hot encoded values. Next is to standardize the our data set, And you can do it something like this. We'll initialize a variable called scalar, and we will make it the standard scalar function from a scalar. We will have a features variable, which will include all the values except median house value, which is going to be our y value. We'll have a target value, which will be median house values. And then we scale those features, and we do it by scalar.fit transform. It gives out a array like structure, and it is not a data frame. And then we use pd.data frame to convert it back into data frames. Data scale features is, now what we do is we say data scale equals to feature scale dot copy, and we just copies everything which is there in feature scale into a new variable called data scale. And then we include the median house value. Why we did transform the median house value? Because we want the original transactional values, or the house values which is there. Now we initialize our main x and y values, and x will be of course all the data set in data scaled except median house values, and y will be only the median house values. Then we'll initialize x train, x test, y train, and y test using train test split from sklearn. And the first value will be x and y. Test size is 0.2. That is, we will use 20% of the full data set in our test set. So it will be equally divided into x test and y test, and 80% will be used in training. Now we have to code the cost function, and the cost function will take four parameters: x, y, w, and b. I'll put up the functions formula on the screen somewhere. So inside the function, what we'll do is we will initialize m, which is going to be the data values. And as you remember, it will be x dot shape index is 0, because x dot shape returns a tuple. Cost will be initialized as 0, 0.0, and for I in range m we implement the formulas, and then we return cost, which is divided by 2 times m. Now writing the gradient part, where we compute the gradient, and we initialize two variables m and n. M remains the number of rows or the data values, and n is the number of columns. Why? Because of course we want to calculate w and b for each column. djdw will be initialized to np.zeros, which will have n zeros, as there will be one value of w for each column, and djdb will be initialized to 0. Similarly, as in cost function, we calculate fwbi for values. We then calculate the error, and then we go on into the gradient descent, that repeat function that we saw earlier. We implement the formula, and then we return djdw and djdb. And now we go on creating gradient descent, which will take in values x, y, w in, b in, alpha, and number iters. Alpha is our learning rate. We initialize jhistory as an empty list. This jhistory will contain all the cost function which this gradient descent will generate. It is a good way to do it, because later on we'll be using this to plot a graph. W is going to copy in all the functions, and I think I have mentioned, and we will import copy as well, and B will be B in. Then for numbers, we implement the gradient descent formula. Now coming down, if you'll see, I have written if I is less than this big number. Why? Because so that it doesn't overshoots or it goes on in the process. It just stops when it exceeds that number, and for every 1,000 iterations we'll be printing it. Okay, and by it I mean all the values that we are generating, which will be wp and jhistory. Now we'll be initializing w init, b init, alpha, and nummeters, which will be feeding it into the gradient descent function. and then we are going to run it and let a model train. It will take some time. And then this is the final weights and bias that we get. Now, what we'll do is we'll create a cost function graph, and using a J history that we have previously initialized and other values, which will be iterations, and this is the graph that we get, and it should look something like this. We will also try plotting our regression line on the actual data set, and this is how you can do it. And you can see that if you're plotting a straight line, it is a very nice fit. Now what we'll be doing is we will be uh, calculating our y predictions, and then we'll be comparing our values to the actual value of y in the y test set. We will also calculate the mean squared error and R2 score, and you can see that mean squared error is quite high because we haven't uh, scaled down the y-test values. Thus, it appears very high, and the y and the R2 score is 64%. For this model, it's really nice.